Welcome to the Statistics 321 video tutorial for how to study for the SAS exam. Your SAS exam is going to come up soon, and what do you need to know in order to successfully study for the exam and successfully pass the exam? So what you should know is your EID and password. Believe it or not, I've had students in the past who forgot their password and had to waste time by going over to the library to get their password reset. Make sure you know your EID and what the password is, and the password can't be locked in your phone because you're not allowed to use your phone at any time during the exam. Number 2, know how to use the full version of SAS, which is installed on the machines. A lot of students use the University Edition or some other version of SAS that they found somewhere on some server, and getting data in and out is a little bit different. So I would highly suggest you find a machine that it is installed on. If you're at VCU, you can go to Harris Hall 2126. There's a bunch of machines that are open that you can go and make sure you know how to do this. Know how to download data and remember where you put it. A lot of people will download the test data and then they can't find it. Okay? Know how to save your SAS code and remember where you put it, because a lot of students will save it and then don't know how to retrieve it to upload it into Blackboard, which is the next step. Upload your SAS code into Blackboard. The other thing you need to do is ensure that your code sheet that you're bringing along with it is uploaded as well. You'll lose lots of points just by simply not attaching it to your exam. So, I would highly recommend that you know how to do these things before you even start worrying about knowing how to code. All right, topics. You're going to have to know how to import a data set. You're going to have to know how to generate some summaries and interpret them. Be able to look at the summaries and say, hey, look, this is probably right skewed, or it might be left skewed. You should be able to look at it and understand the difference between a mean and a median and dig those out. You should know how to combine data sets, because I pretty much guarantee you will have two data sets which you will need to merge together in some way or another so that you can complete one of the problems. Some of the data will probably be in one of the data sets, another part will be in another data set, and you're going to have to put them together. All right, you're going to have to know how to subset data sets. So, for example, I might give you a massive data set and have you do work on just a small portion of that. You should know how to do that. You should know how to create plots, know how to use histograms, or create histograms using proc univariate, box plots, scatter plots, side-by-side box plots. Whether you use SGplot, Gplot, or just the basic plot, which looks pretty hideous, I would suggest that you know how to do these things and know how to get good pictures out. The most important thing, though, is comment on what you see in the plots. A lot of times students will just make a plot. Well, half the credit is telling me what you see in the plot. I don't care necessarily how much coding you know how to do. If you don't know what it means, it's not worth anything to me. So make sure you know how to comment. Histograms, you always comment on the center, the shape, the spread, and any unusual features. Box plots, you're going to look and see if there's unusual features. You can tell about the shape, the spread, and the center in those as well. Scatter plots, you would tell me whether it's linear. Tell me if it's positive direction, negative direction, and how strong of a pattern do you see there? Side-by-side box plots, you're going to be looking to see, does one group clearly stand out from the other group in the sense of, is the data shifted one way or another? If you don't include these comments, don't expect to do well. Okay, you're going to need to fit a regression model. Interpret the coefficients in terms of the problem. For example, for each 1 unit increase in something, we expect a blank unit increase in whatever the other variable is. Okay, you need to be able to create confidence intervals for those and interpret them. Comment on how well the model fits the data. If you fit a line through something, look at it. Does it look like it fits well, or is it kind of awful? Determine if the predictor variable is significantly influences the outcome variable. It may or may not. You need to be able to determine that and write a hypothesis test for it. And you should know the model assumptions and be able to look at some diagnostics and say, yeah, this is good or this is bad. ANOVA. This is a common statistical test. You should clearly state the hypothesis in both the words of the problem as well as in mathematical notation. You should have something like mu1 equals mu2 equals mu4, blah, 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 blah. Okay? And you can write out the words, mu, and then just put 1. Okay, so you can do this. You need to go through all the steps of a hypothesis test. You can't just say, here's the hypothesis, here's the p-value, I'm done. No, you have to tell me, what is your significance level? What is the test statistic you're using? And you can just say, I'm using ANOVA, Proctor, LM, and SAS. But you have to tell me how you're going to calculate it. You have to just say, I use this decision rule and what the conclusion is from it. You should know how to conduct a post hoc test to identify where differences exist. You should also know the model assumption. Okay, study tips. Get in groups or pairs. I know you've heard this before, but actually do it. Find some problems in textbooks or online. Okay? Find the ones that don't have solutions. Why? Because on the exam, you're not going to be able to look at a solution and go, yep, that's how you do it. So do the problems independently. So you're in groups or pairs, everybody goes off, does the problem, comes back, and then they look at the solutions of each other and then go, oh, I forgot this, I forgot that. This is what I need to learn about. This is what I need not to forget. And you can put that in your code sheet. You can put something in there. Don't forget to put this. All right? Compare your work, find out what you know and what you don't know. And that's the key. Identify what you don't know. Then study what you don't know. A lot of students spend a lot of time studying things that make them feel good. Yeah, I know that. Problem is they don't. And that's what they do, is they study what they do know, avoid what they don't know, hoping that I won't put it on the test, and it's usually there. Okay, so then right before the exam, go over the material one more time, and then go take a walk. I usually when I was a student, I would take a walk a half an hour before every exam. Clears your head. You come in right before the exam starts, and you can just jump at it, and you usually do quite well because your brain isn't just scrambling trying to find all this stuff. You go in, your head's clear, you'll be doing much better than you would otherwise. All right, good luck on the exam.